Hey folks, how's it going? This is Mr. Murray coming to you with a video for May 12th, 2020 for Course 1 Honors. This video we're going to be continuing with another little example about graphing exponential functions. So here we have the function f of x equals 1/3 times 3 to the power of x minus 1 plus 2. What I want you to do, think about how to work smarter, not harder when plugging in numbers here. You're going to go ahead and make a table and use that table to create a graph. So again, pause the video, make your table and graph. Then when you're ready, unpause, and you can see what I got. Okay, so I'm going to recommend that you start by plugging in 1. And the reason I'm going to suggest 1 is because when you plug in 1 for x, you get 1 minus 1 is 0. So you zero out that exponent. And then you get 3 to the 0 is 1. A third of 1 is a third. And then 2 plus a third is 2 and a third. So start by plugging in that nice easy number. Now I'm going to plug in 2. So 2 minus 1 is 1. 3 to the 1 is 3 because anything to the 1 is itself. A third of 3 is 1. And 1 plus 2 is 3. Now I'm going to plug in 3 for x. So 3 minus 1 is 2. 3 to the 2 is 9. A third of 9 is 3. 3 plus 2 is 5. Now I plug in 4. 4 minus 1 is 3. 3 to the power of 3 is 27. A third of 27 is 9. 9 plus 2 is 11. And at this point I see 11, so I'm going to stop going in this direction because if 11's off the graph and we're going up, then the numbers after this are just going to be even more off the graph. So now I'm going to fall down to 0. Go the other direction. So I'll write these ones out. 0 minus 1 is negative 1. 3 to the negative 1 is a third because of the negative rule. A third times a third is a ninth. 2 plus a ninth is 2 and 1/9. Okay, then we'll plug in negative 1. Negative 1 minus 1 is negative 2. 3 to the negative 2 is 1 over 3 squared, which is 1 over 9. A ninth times a third is 27th. Is it 27th? So now we can see that it's going to be hard to graph, but we can actually see where the asymptote is going. So let's try to graph these out. So we have 2, 3. We have 3, 5. And we have 4, 11. Then we have 1, 2 and a third. So that's about here. 0 rather is 2 and a ninth. And then here we have 2 and a 27th. So let's see how well I can draw this on the spot. So here's my graph. It's not a perfect asymptote. But then I go up like that. And it needs to also, so let me just fix that ending, because it needs to go through that point here. Okay, so that's basically what we get here. That's basically what we get here. So what we have here is we have this little graph of our exponential function. Okay, we'll make sure to put arrows on both ends. Now we can see we have this horizontal asymptote here, right? It gets, because you can see it's getting really close to 2, but it's never going to actually reach 2, and it's never going to dip underneath 2. And then on the other end, it shoots off to infinity, actually very rapidly. If we were going to plug in 5, by the time we plug in 5, we would be at 27. So we'd be at 29. Then we'd be at 83. It'd be at 245. It'd be at 730. So you can see we're getting really large really fast as we're going to the right. So if we're able to get this graph right, I actually did this one ahead of time and I got something kind of like this. So you can see they're pretty similar. Let's talk about some analysis now. So let's see if we can figure out what's the domain and range of this graph. The domain is negative infinity to infinity. And again, you can plug whatever you want in there. If you choose any number in the world, you can always plug it in. The range here is going to be, it's going to start at 2, open parenthesis because it never reaches 2, and it's going to go to infinity. And I know that because the graph points up. So the horizontal asymptote of y equals 2 needs to appear in your range. Either as the first number, if it's a graph that starts, that goes above the asymptote, or as the second number if your graph's below the asymptote. So it depends, right? There, I did an example of each between today and yesterday. Okay, x-intercepts and y-intercepts. In this case, there is no x-intercepts, okay? Because if you think about it, if it can never touch 2, it can never get below 2. If it can never get below 2, there's never going to be any x-intercepts because it's never going to get to 0. And the y-intercept is 0, 2, and 1/9. It is increasing always. So from negative infinity to infinity. It's decreasing never. As you go from left to right, you're always going up. Maybe not by a lot, but you are always increasing. The horizontal asymptote, as I said, is y equals 2, that flat line. Where is it positive? Here it does happen to be positive everywhere, right? The y values are always more than 0. They're never negative. And now for M behavior. Okay, so as x approaches negative infinity, what's happening with f of x? Well, it's leveling off, right? So as x gets smaller and smaller, gets more and more negative, f of x is approaching 2. Okay, it's getting really, really close to, maybe not equal to, but sufficiently close to 2. Okay, and as it goes to infinity, the upwards pointing arrow tells me that f of x is going to infinity. Okay, so two big skills that we're talking about here. Skill 1 is the graphing of the exponential functions, making the table, graphing it out. And skill 2 is doing the analysis. Again, continue to look for patterns here because there are certain patterns that if you can think about them and seek them out, it makes doing the analysis a lot easier. Anyway, hopefully you're able to get everything right. Best of luck. Don't forget to love math. And remember, you can do it. Until next time, have a great day.